All right, good morning, class. It is a already hot Thursday morning. I know I was a little late on this video. I apologize about that. It's been a really busy week. We've been trying to get all the link crew leaders together. Mrs. Greminger and I met, and then with the ASB, I'm trying to get all the leadership officers and everything going on. I was helping out with senior checkout yesterday, so I'm finally able to give you our last topic of this school year. I cannot believe it. You guys have been really good. I know with the last assignment, over half of you submitted it and you guys got really good grades on it. So I appreciate you guys working on that. I can tell you right now that this topic, at first you'd be like, what the heck is going on? The main goal of this video, I'm going to try not to have it be too long, is just to expose you to the laws of exponents. I'm not expecting you to be masters at it right after this video, but I need to show you 5 main properties of exponents, 5 main laws of exponents. I want to expose that to you so that way you have some sort of an idea when you guys go over it this fall in Integrated Math 2. I want to let you guys know that this is literally from the Integrated Math 2 textbook. It is chapter 1. So you guys should be, after maybe a little bit of review, you guys should be starting with exponents in Integrated Math 2 this fall. And please watch this whole video so that way you can be kind of exposed to it. So that way in the fall, you'd be like, you know what, I kind of remember that. Oh yeah, this is when you add the exponents or subtract the exponents, for example, okay? Now, on the Google Classroom, I also downloaded a PDF of this. This is exactly gonna be in your Google Classroom. It has the 5 main laws there. So after you watch this video, please click on that PDF and read through it as well, okay? Okay, 5 main laws, here we go. I'm at my house right now, so it's a little, kind of messy. My office. Okay, our first law of exponents, all right, is the 0 exponent. This is probably the easiest of all the laws. That's probably why it's number 1. Anything raised to the power of 0 always equals 1. Okay, here we go. The first law of exponents. Anything with a 0 exponent always equals 1. Now, before I do that, I'm going to, let's just have this, 5 to the power of 0. Let's kind of define a couple terms. The main number, that's called the base, all right? That little number up to the side, that is always an exponent. I'm sure you guys have, dealt with exponents or heard that term before. I know I've said it before as well. So for example, if I have 4, 2, 4 is my base, 2, that means it's a square, right? That means it's not 4 times 2, but it's 4 multiplied by itself 2 times. So 4 squared would be 4 times 4, that's 16. Let's go 5 to the 3rd power. Well, it's not 5 times 3, but it's 5 multiplied by itself 3 times. So 5 times 5 times 5. So the main number is the base. That exponent right there, it's just raised to the 3rd power. So sometimes I'm going to be using power and exponent interchangeably. They essentially mean the same thing. So 5 raised to the power of 3 or 5 to the 3rd power. You guys get the gist. The 3 is the exponent, that 5 is the base. So 5 times 5 is 25 times another 5 is 125. So 5 with an exponent of 3 equals 125. 4 with an exponent of 2 equals 16. So that's when I say our first law of exponent, anything raised to the power of 0. Well, what the heck? Here's our 5 is our base. It's raised to the power of 0. That doesn't even make any sense, right? So anything raised to that power of 0 always equals 1. Okay? Now, let's just say if we had 5 to the 1st power, well, that's just 5, by itself, 5. So I want you to see all these differences right here. 5 to the power of 0 is 1. Anything raised to the power of 0 is 1. Here we go. If we have 5 to the 1st, that's just 5 by itself. So there's 5. If we were to do 5 to the 2nd, that's just 5 times 5, that's 25. And we already did 5 to the 3rd. So I'm hoping you guys see a little pattern here. You're like, okay, Mr. Wallace, well, what about if we have, I don't know, a variable? If I have a, right, I'm going to do another example here. What's a to the power of 0? Well, it doesn't matter what a is. Anything to the power of 0 always equals 1. It doesn't even matter if we have a variable. I could have 427 to the power of 0, and guess what it equals? 1. And if we were in class, I always did this in the previous years as kind of a, a joke to be funny. I can have 5x, y, 7, g, pi, the natural log. That's a crazy number. But if the whole thing is raised to the power of 0, guess what, guys? It's always 1. Okay, so the first law of exponent, anything raised to the power of 0 is 1. Shoot, I'm already at 6 minutes. Ugh. All right. Second law of exponents is probably the most confusing. So we went from the easiest to probably the most confusing. Once again, this is going to be on the Google Classroom, this PDF. Whenever we have negative exponents, you need to use the reciprocal to make it positive. The reciprocal just means flip. If I have 5, I keep going back to 5. Well, technically, that's 5 over 1, right? 5 as a fraction is 5 over 1. Reciprocal means you just flip the 2. The numerator goes to the denominator, and the denominator goes to the numerator. So reciprocal just means flip. So if we were to use the reciprocal of 5, it would literally be 1 over 5. You just flip those numbers, okay? So for example, here we go, negative exponents. Let's just say if we have, this is law number 2. Let's just say if I have 4 to the negative second power. Oh shoot, we can never have negative exponents, right? So that means we have to flip everything. Well, 4 to the negative second power, to make it easy, just imagine everything over 1. Well, to get that exponent positive, we have to flip it. We have to use the reciprocal. So that then becomes 1 over 4. So the base follows it. But now, once it crosses that threshold, once it goes down, that negative exponent becomes positive. That's the point of using the reciprocal. Whenever it goes from top to bottom or from bottom to top, that sign of that exponent changes. So, well, we know what 4 to the power of 2 is. That's 16. So it's 1 over 16. So any time pretty much that we have a base and a negative exponent in the numerator, we're going to have a fraction, right? And if you knew how to manipulate a calculator, if you did type in 4 and then hit the exponent button of negative 2, it would give you 1 over 16 as a decimal. All right, so if you just did 1 divided by 16 on a calculator, you get the same thing. Okay, so negative exponents, you have to flip. I'm going to do 2 more examples on the second law. Okay, so what if I have a variable? All right, what if I have x to the negative 7th? Right? The simple instruction is just simplify. Right? Well, we don't know what x is, so we can't do x times x times x times x times x. We don't know what x is. That's fine, but simplify. We can't have a negative exponent. All right, so we just have to get rid of the negative exponent. And that's, if you would imagine it as over 1, hey, just use that reciprocal. X to the negative 7th, if we want to simplify, flip up, flip that 1 up, flip the x and the 7 down, then it becomes 1 over x. Once we flipped down, then it became positive. Okay, please don't keep that 7 negative because that's the point of using the reciprocal. That's the point of flipping it down. Okay, so x to the negative 7th, well, we just flip it. Once you flip, that exponent becomes positive once you use the reciprocal. Okay. Now, okay, here we go. What if we have this? 1 over, let's just use b to the negative 5th. What if we have a negative exponent at the bottom? Well, guys, it still follows the same rules. We can't have a negative exponent, so we just use the reciprocal. We flip it up. So it goes both ways. If there's a negative exponent on the top, it's going to be positive on the bottom. If there's a negative exponent on the bottom, well, flip it, then the exponent is positive on top. So technically that's b5 over 1, but we don't need the over 1. There we go. Okay, very brief rule of the negative exponents. I'll give you one more example real quick. If I have 1 over 2 to the negative fourth, and I'm asking you to simplify. If I have 1 over 2 to the negative fourth power, well, we can't have a negative exponent. I'm going to flip it. So it becomes 2 positive 4. So once I flip it up, then it becomes positive. Well, I know what 2 to the fourth power is. That's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right. You guys are going to get way more practice this fall with it. And once again, this is just kind of exposing you to the rules. Okay, 3 more rules left. All right, please read this on the Google Classroom. I'm going to flip the page over. Rule number 3. This is the product of powers. So if you have the same bases that are being multiplied, you add the exponents. So that's basically the third rule in a nutshell. If you have the same bases, so let's just say x to the 7th power times, and that's what that little dot means, x to the 4th power. So I have x to the 7th times x to the 4th. Well, are these the same bases? Well, obviously, yes. They're the same letter, the same variable, so they are the same base. When you have 2 of the same bases that are being multiplied together, you add the exponents, okay? Equals, well, 7 plus 4, that's easy. X to the 11th power. There you go. And we don't know what x is, so we cannot simplify anymore, okay? Now, for those of you that want to explore this further, I would encourage you to do something like this to prove this, okay? So let's just say if I have, 4 to the 3rd power times 4 to the 4th power. Well, let's look at these bases. 4 is the same as 4, obviously. So those are the same bases, and they're being multiplied together. So that means we add the exponents. So this would be 4 to the 7th power. Okay. Now we know what 4 to the 7th power is because, we actually have a number. We can multiply that out. We can figure that out because it's not a variable. Okay. Now I'm filming on my phone, and that's going to be a relatively large number, and I can't use my calculator right now because I'm filming. So if you guys have a calculator or even a basic calculator, just hit 4 times 4, do that 7 times, and you're going to get your answer. You're going to get your solution. Here's what I want you to explore to prove it. If you hit 4 to the 7th power, you're going to get a number. If you did 4 to the 3rd power, which is 64, times 4 to the 4th power, which is basically 64 times 4, you get a number there. They're going to equal the same thing. So you can explore that, okay? So anytime we have the same bases that are being multiplied, you add the exponents. So, all right, so one more example. 2 more examples. If I have 9 to the 11th power, that is a huge number, times 9 to the 3rd power. Okay, well, same bases that are being multiplied together, you simply add the exponents. 11 plus 3 is 14. So that's 9 to the 14th power. That is a massive number. Okay. What if I have y to the 7th power times y to the 10th power? Well, we don't know what y is, so that's a variable. Well, same bases being multiplied together, you add the exponents. So that's y to the 17th power. I think you guys hopefully are getting see the pattern. Now what if I have this? Z to the 2nd times x to the 3rd. Can I simplify that at all? The answer is no. I don't know what z is, so I can't, use the square of it. I don't know what x is, so I can't use the cube of it. That's with 3. And they're not the same bases, so I cannot add it. So a lot of people I've seen in the past will do this. Oh, that's zx to the 5th. No, can't do that. No, don't do that. Not the same bases, so no rules of exponents apply here. Okay, so this is rule number 3. 2 more rules. They're very similar to the one we just did. Okay, so this one is now quotient of the powers property. So this is basically, if you have the same bases now, instead of being multiplied like in the previous one, same bases that are being divided, you subtract the exponents. Okay, I'm not going to spend too much time on this one because it's very similar. So if I have x to the 7th divided by x to the 3rd, now it's also written like this, x to the 7th divided by x to the 3rd. Obviously, guys, these mean the same thing. This divided sign and this fraction sign, well, that line is division. So it's just represented in, different ways, both ways. If same bases are being divided together, you subtract the exponents. 7 minus 3 is 4, x to the 4th. 7 minus 3 is x to the 4th. Okay, same bases, you subtract the exponents. 2 more examples. If I have 11 to the 15th power, huge number, divided by 11 to the 10th power, another huge number, well, look, same bases, they are being divided, so you subtract the exponents. That would be 11 to the 5th power, which is a huge number. And because I'm using my phone to film, I can't use my calculator to figure out what that number is. But in the future, you will want to figure that out. You can simplify this further. 11, hit the exponent button, 5, 11 to the 5th power, you get a big number. Now, this is where it gets a little tricky. What if we have something like this? This would be like a test question, like simplify. If I have x to the 4th power divided by x to the 8th power. If we subtract, so we have the same bases that are being divided, we subtract the exponents. Okay, so let's subtract them. What's 4 minus 8? Well, that's x to the negative 4th. Okay, but is this our final answer? No, we can never have negative exponents. So it goes back to our law of exponent number 2. We can't have negative exponents, so we have to, once again, incorporate the second law, use the reciprocal, flip it to make sure that negative exponent becomes positive. So that's 1 over x to the positive 4th. Okay, just like we did a few minutes ago. Okay, so whenever we subtract, we always can run into the problems that we're going to have a negative exponent. Then we have to apply rule number 2. Okay, so same bases, you subtract the exponents. Last one. Thank you guys for watching. I'll have more details on the Google Classroom, but there is going to be no assignment on this. Your assignment is just to watch this video and read through this PDF that I put on. This will be the last week that we do attendance. I am putting in grades either what did I say? Oh, yeah. So work is due the 1st, Monday the 1st. I am putting in grades on June 2nd. So that's your last opportunity to get your grade up. Okay, power to a power. Here we go. The 5th main law of exponents. Pretty simple. It goes back to the same thing. If we have power to a power, so let's just say if I have 3 to the 3rd power. So there's 3 to the 3rd power. Well, we know that's 3 times 3 times 3. So that's 3 times 3 is 9 times 3 is 27. But what if we have a base and an exponent raised to another power like that? So notice, unlike the previous 2 laws, there's only one base here. That's 3. So 3 to the power of 3, that whole thing to the power of 5. Well, the 5th rule is if there is a power to a power, you multiply the exponents. So you see that pattern, right? If there's 2 bases that are being multiplied, you add the exponents. 2 bases that are being divided, you subtract the exponents. But here, power to a power, there's really essentially only one base, but it's raised to 2 exponents. That's when you multiply the exponents. Okay? If it seems a little confusing, it's okay. You're going to have a lot more practice with this later. So that would be, well, let's see, 3 times 5 is 15. That would be 3 to the 15th power, right? Which is a huge number, okay? If I have x to the power of 7, if that's raised to the power of 4, well, one base, so that's power to a power. That would be x to the 28th power, because that's 7 times 4. Okay. All right, guys, thank you for watching. I'm going to upload this. You guys are amazing. I will have a few more announcements probably early next week to say my official goodbyes. I know this video went a little longer than I thought, but I wanted to go just in a little detail about the 5 laws of exponents. Thank you, guys.